Hi guys, welcome to this video on reducing radical numbers. We are going to learn to reduce radicals because it's a very important skill for simplifying the answers to our quadratic equations. When we do the quadratic formula, many times we get fractions that we need to reduce, but the problem is that the radical term doesn't have something to reduce out front. So if we simplify that radical and reduce it, we can then divide and get rid of the bottom of our fraction. So that's why we're going to do this. So to simplify radicals, um, rather than looking for perfect squares within a number or variable, the way it is shown in most books, I choose to do the problems in a different way, and here's how. Step 1. Find the prime factorization of the number inside the radical. So what that means is you're going to divide the number by 2 because 2 is the first prime number, and continue dividing by 2 until you get a decimal or a remainder. Then divide by 3, 5, or 7 until only the numbers left are prime numbers. Factor any variables inside of the radical. Step 2. For our purposes, okay, it's always going to be, for our purposes, step 2, every single radical is going to be index 2. We're always going to be taking the square root while we're doing this, okay? So it's not that this isn't too big of a step. You just need to confirm that you're working with a square root. What happens is that power of 2, that index of 2, tells you how many numbers of a single kind you need to put together to be able to move it outside of the radical. So for example, I would need 2 3s to be able to move those outside of the radical as a single 3. Then move each pair of numbers or variables from inside the radical to outside. If there are not enough numbers or variables to make a group of 2, then leave those numbers or variables inside the radical. Each group of numbers or variables gets written once when they move outside because they are now one group. So 2 numbers becomes one group and is written outside. This is the same way GCF factoring works. Step 4 is to simplify expressions both inside and outside the radical by multiplying. Multiply all numbers and variables inside the radical together, and multiply all numbers and variables outside the radical together, but do not multiply the two values that are inside and outside together. You cannot because of that radical symbol. It's like a force field. So let's take a look at a guided example. So square root of 252. So what I'm going to do is find the prime factorization of 252. So I am going to take 252 and I'm going to divide it by 2 because 2 is a prime number. All right? So we are looking for numbers that are not prime. We're going to continue to factor those, but if we do get prime numbers, we're going to leave it alone. So 252 divided by 2 gives me 126. I know that 126 is not prime, so I'm going to try dividing that by 2 again. And I get 63 and the 2 that I factored. 63. I'm going to try to factor that then. I can factor 63. So I'm going to need some extra space over here. So I'm going to start again over here. So 63. So continuing over here. 63 can be split into 9 times 7. That's a 9. All right. 7 is prime, but 9 can be split into 2 further prime numbers of 3 times 3. So that's it. I've broken it down. I've got a 2 here, a 2 here, a 3, and a 7. I have reduced 252, okay, into 2 times 2 times 3 times 3 times 7. So if you go ahead and punch in 2 times 2 is 4, times 3 is 12, times another 3 is 36. 36 times 7 will get you 252. So what we are then going to say is this is the equivalent of the square root of 2 times 2 times 3 times 3 times 7. So since it's the square root, I'm looking for, since it's the square root, it's index 2. I'm looking for groups of 2 identical prime factors. So 2 and 2 are a pair, and 3 and 3 are a pair. So what I can do is write it as such. 2 times 3 times, and now what's left is square root of 7. So I can then multiply 2 times 3 on the outside to get 6 times the square root of 7 as my simplified expression. So to test this, all right, what you can do is you can take a calculator. I'm going to prove to you that these are equivalent expressions. Type 252 into the calculator and take the square root of that number. If you take the square root of 252, all right, you get 15.874. Now, if I take the square root of 7 and multiply it by 6, I should get the same answer. So I'm going to take 7, the square root of 7, and multiply it by 6. And when I do, I indeed get the exact same expression, 15.874. So 6 square root of 7 is the reduced radical for square root of 252. So let's reduce some of these radicals here. All right, these are some pretty common ones, so let's reduce them. All right, 8. So I'm going to break 8 down. I can break 8 down into 4 and 2. And then 4 is not prime. 4 can be broken down into prime numbers, so I'll reduce it into 2 times 2. So now I have 3 2's here, so I can take 2 of them out. So I'm going to take these 2 out, and I get 2 multiplied by the square root of 2. That's it. There's nothing else left to factor. There's nothing else left to simplify. There's nothing else left to multiply. Square root of 8 is equal to 2 times the square root of 2. All right, let's try square root of 27. So square root of 27. I can break 27 down into 9 times 3. I know 3 is prime, but 9 is not. If I try dividing 9 by 2, I get 2 and 4.5. That doesn't work. I can't have any decimals here, so I'm going to try 3 instead. So I'm going to do 3 times 3, which is great because now I have, again, these two pairs of 3's. So 2 pairs, the pair of 3's here is what's going to get pulled out and be the 3 out front times 3. Square root of 3 because this is what is left. So I'm going to go ahead and just pick this. Oh, I can't. Well, too late. That is what is going to get. So 27, square root of 27 is equal to 3 times the square root of 3. Let's try square root of 32. So I'm just going to keep dividing by 2. So square root of 32, I'm going to split it into 2. I know it seems tedious, but this is a surefire way to do it. So 16 times 2. All right, so I know that 2 is prime, so I'm going to keep going. I can't go any further down on that tree. So we'll do 16. We'll split it into 8 times 2. We're going to go ahead and split this 8 into 4 times 2. And then we're going to split this 4 into 2 times 2. Until I am left with just a bunch of 2's. So I have 1 pair. And I have a second pair. So what I can do is now write my 1 pair as 2 times this second pair out here, another 2. And this 2 here is left underneath the radical sign. So then I would multiply the 2 times the 2 out front to get 4 times the square root of 2. So square root of 32 is equal to 4 times the square root of 2. Alright, and let's try 75. So, I'm going to split 75 into its two components. Or I'm going to try dividing it by 2. So 75 divided by 2 is 37.5. Unfortunately, I get a decimal. That's not going to work. No decimals here. So instead, I'm going to try doing 3. So 3 times 25 will give me 75. Okay. 3 is prime, but 25 is not. I can break 25 down into 5 times 5. Okay, I have 5 and 5 are prime, so I have one pair of prime numbers that I can go ahead and yank out. So I'm going to pull these two 5s out. So I get 5 because they become one group now, and times the square root of 3 because that 3 doesn't have a pair. So square root of 75 is equal to 5 times the square root of 3. So that's simplifying radicals. I hope that you guys get a good feel for this. And that's it. I'll see you in the next video.